Okay, in the next few videos, we're looking at finding arc length, area of a circle, but now instead of with degrees, but in terms of radians. Now, we know that this, for example, this L would be the arc length of a circle with radius r and angle subtended at the center, theta degrees. Now, in degrees, we write arc length equals, which is L equals, theta, how many degrees out of 360, times 2 pi r. However, if the angle theta is given in radians, we would say that the arc length is theta over, we know that 360 is 2 pi, so it would be theta over 2 pi radians. So theta radians over 2 pi radians times 2 pi r. Now we know that the 2 pi's cancel and we've got L equals theta times r, or it's L equals r theta. So therefore, to find the arc length of a circle, if you know the angle in radians, it's L equals the radius times theta, where theta is in radians. Okay, we'll just look at a couple of examples. So, first example, I will just do question 1E from exercise 5.3. Find the exact arc length of a circle with radius 7 millimeters and angle subtended is 45 degrees. Now we know that theta needs to be in radians, so it's 45 degrees, which is pi on 4 radians. Okay, so arc length, L equals r theta, which is 7 times pi on 4, which is 7 pi on 4. That's the arc length, so it's 7 pi on 4. Now, that is in, that's the exact arc length. You could then, for example, change that you can maybe find that to 1 or 2 decimal places by just doing 7 pi divided by 4 on your calculator if you were asked to give the arc length in, say, to the 2 decimal places. However, if you're not asked for any rounding, you should always give exact answers. So 7 pi on 4 is an exact answer. There'll be times when if you give a rounded answer and they want an exact answer, you are going to lose a mark. So always write down your exact answer at some stage, okay? Okay, so second example here, find the arc length to 2 decimal places if the radius is 5.9 centimeters and the angle subtended is 23 degrees 12 minutes. Again, L equals r theta. In this case, theta is 23 degrees 12 minutes. Now we need to change that to radians, so it's 23 degrees 12 minutes times pi over 180 degrees. So it's going to be 5.9 times 23 degrees 12 minutes pi over 180, and you would enter that into your calculator. That is 2.389, which to 2 decimal places is 2.39. Okay, so these angles, this angle has been given to you in degrees, so you need to convert it to radians. In some questions, they will just give you the angle in radians and you would just put it straight in. So if you're already told that the angle is pi on 4, you would just put that straight in. Okay. Okay, another question. The radius of a circle is 3 centimeters and an arc is 2 pi over 7 centimeters long. Find the angle subtended at the center of the circle by the arc. We know that L is r theta. We know that the arc length is 2 pi on 7. The radius is 3 times theta. And if we just rearrange this equation, we would get that 2 pi over 7, this 3 would come down here. So times 3 equals theta. And so therefore theta is 2 pi over 21. Okay, so that is the angle subtended at the center. Okay, now last question, question 10. A sector of a circle with radius 5 centimeters and an angle of pi on 3 subtended at the center is cut out of cardboard and it is then curved around. So we've got that this is 5 centimeters and the angle is pi on 3 and this is the arc length. It's then curved around to form a cone. Find the exact surface area and volume of the cone. So we know just to find this arc length here, L equals r theta. So it's 5 times pi on 3, which is 5 pi on 3. That's that arc length. But when I form a cone out of this, this L, right, will now, this will wrap around, this whole distance here is now L. L will now be the circumference of the base of this cone, and this length here, the radius of the original sector, is now the slant height of the cone. So this distance around here now is L, which is 5 pi on 3. So basically the circumference of the circle down here is 5 pi on 3. Now, to find the surface area and volume of a cone, we should write out what the formulas are. Now, surface area of a cone is the area of the base, which is pi r squared plus pi rl, well, I'll call it pi rs, sorry, where s is this slant height here. And we know that, I'll look at the volume of the cone in a minute, all right? So circumference around here is 5 pi on 3. We also know that circumference of a circle is pi d, or 2 pi r. I'll write 2 pi r. So therefore, we know that 2 pi r equals this 5 pi on 3. So now, making r the subject to find the radius of this actual circle, we can divide by pi r, and we've got 5 pi over 3, and put this pi r down here. Sorry, just this 2 pi, sorry. Divide by 2 pi. So divide it by, I'll just put pi 2. So we've got the pi's cancel, and we've got 5/6. So the radius is 5/6 of a centimetre. So we have 5 pi on 3, divide by the 2 pi, okay? Pi's cancel, it's 5 on 6. So therefore, now we can look at the surface area of the cone, which is pi r squared plus pi rs. So it's pi times 5/6 squared plus pi times 5 over 6 times the slant height is 5. So that's 25 pi over 36 plus 25 pi over 6. So you're just adding the fractions 25 over 36 plus 25 over 6, making a common denominator there of 36. You'd get 150, I think 175 pi over 36. That would be the surface area of the cone. And of course the units are centimetres squared because it's area. Now, that's your surface area. Now the volume of a cone is pi r squared times h, where h is the perpendicular height. Problem is we don't know the perpendicular height of the cone, but we do know that the radius of the cone is 5/6. So I'm going to draw here, if I look up here and put a perpendicular height, that's h, that's my slant height there, which is 5. I've got h there, my radius is 5/6, and my slant height there, or the hypotenuse in this triangle, is 5. So therefore, h squared is 5 squared minus 5/6 squared, which is 25 minus 25 over 36, which is 24 and 9/36. So h is, you can just do that on your calculator actually, I'm just doing it there in my head. So it's 24 and 9 over 36. That's h squared, therefore h is the square root of that. Writing that as an improper fraction, it's 873 over 36. So h is the square root of that. Now square root of 36 is 6. This is divisible by 3, and it's actually divisible by 9. So it's going to be 3 root. So to simplify, so therefore as h is the square root of 873 over 36. Now square root of 873 can be simplified as 3 root, just working that out. So 3 root 97 over 6, which is root 97 over 2. That's h, perpendicular height of the cone. So therefore the volume is going to be pi r squared times this h. Remember the radius is 5 over 6. Okay, so this radius is 5 over 6. So volume is pi r squared h. which is pi times, now r squared is 5 over 6 squared, and h is root 97 over 2. So it's pi, and 5 squared is 25, root 97 over, this will be 36 times 2, which is 72. Sorry, just a little error. It's a third pi r squared h. So that's a third times that, which is 25 root 97 pi over 3 times 72, which is over 216. And if we, so that's the exact answer, that's approximately 3.58 to do 2 decimal places. Even though the answer in the solutions is different to this, it also approximates to 3.58, so they are the same answer. I really can't see how we can simplify square root of 97. So, okay, now exercise 5.4, area of a sector. Now, if theta is in degrees, the area of a sector is theta over 360 times pi r squared. Okay, that's if we're given theta in degrees. However, if theta is in radians, then the area is still theta, but theta has to be in radians this time. Now 360 is 2 pi, so over 2 pi times pi r squared. Now just doing some cancelling here, we've got theta r squared over 2, or we traditionally write this as the area is a half times r squared theta. So therefore the area of a sector is a half r squared theta, where theta is in radians. So that's your second formula that you need to know. Okay, so basically the same as arc length, except we're working out area this time, and theta has to be in radians. So we'll just do a couple of questions. Okay, the first question, question 2a, find the area of a sector to 2 decimal places given that the radius is 1.5 meters and the angle subtended is 0.43. Now this angle is given in radians, it's not in degrees. So area is a half r squared theta, which is a half times 1.5 squared times 0.43 radians. And just working that out. Area is 0.48 to 2 decimal places, meters squared. Okay, another question here. So the area of a sector of a circle that is subtended by an angle of pi on 3 at the centre is 6 pi meters squared. Find the radius of the circle. So area equals a half r squared theta. So our area is 6 pi. We've got a half times, we don't know what the radius is, and we know that theta is pi on 3. So therefore we've got 6 pi equals, just making one numerator, one denominator, pi r squared on 6. So now rearranging and making r the subject, I would have 6 pi times 6 over pi equals r squared. The pi's cancel. So therefore r squared is 36, therefore r is 6. It's plus or minus 6, but as r is positive and it's a length, r is 6. Okay, so the radius of that circle would be 6. Question 10 here. The area of a sector is 3 pi over 10 centimetres squared, and the arc length cut off by the sector is pi on 5. So we know that the area of the sector with radius r and angle subtended theta, the area is 3 pi over 10. And the arc length cut off by this same sector is pi on 5. So the arc length is pi on 5. It says find the angle subtended at the centre of the circle and then find the radius. Now, because we know that the arc length here is pi on 5, look, it looks like we've got 2 unknowns. So let's just set up some equations. Let's write the equations for area and arc length. Okay, so area is 3 pi on 10, arc length is pi on 5. We know the formula for area. Area is a half r squared theta. Arc length RL is r times theta. So area is 3 pi on 10, which is a half r squared theta. Okay, and L, which is pi on 5, equals r times theta. I'm going to rearrange this, put that 2 up there, and I get 6 pi over 10 is r squared theta, or I've got that r squared theta is 3 pi on 5. And here I've got that r theta is pi on 5. So it's like I'm solving simultaneous equations. I'm going to go equation 2, equation 1. I want to rearrange this one. I'm going to make theta the subject. So theta is pi over 5r, and I'm going to sub that into equation 2. So I've got theta is pi on 5r. So therefore r squared times pi over 5r, because that's what theta is, equals 3 pi on 5. And making r's cancel here. So we've got r pi on 5 equals 3 pi on 5. Of course, one of these r's. So that's 5r. So this r cancels with one of these. I've got r pi, or pi r on 5, equals 3 pi on 5. We can just see here clearly, just by observation, that r is 3. Or we can say r is 3 pi over 5 times 5 over pi. These cancel, and I get that. Sorry, you can't see that. So r is, taking this over, we get that r is 3. So now that we know that the radius is 3, we can just substitute in here to work out theta. So I can, so therefore, we know that theta is pi over 5r, which is pi over 5 times 3, which is pi over 15. And so we were given 2 pieces of information there. We had the 2 unknowns of r and theta, and that's why we had to solve simultaneously. And we've got our answers there. That's the end of the examples for exercise 5.3 and 5.4.